Okay, today we're going to be looking at the 2016 exam. This is question number 6, which I've classified as a type 5 problem. Type 5 is calculus from tables. And this is a very straightforward problem with some pretty fundamental calculus questions. Finding derivatives, tangent lines, finding derivatives, evaluating derivatives, and then also finding antiderivatives, or actually a definite integral. So part A says, let k of x equal f of g, write the equation at x equals 3. So right away, if I'm going to write a tangent line, I need to know what k of 3 is and what k prime of 3 is. So k of 3 would be equal to f of g of 3. And to evaluate this, we go to the table. G of 3 is 6, so this is the same thing as f of 6. And we want to evaluate f of 6. F of 6 is 4. Okay. Now we're going to do k prime of 3. So we need to take the derivative and evaluate it at 3. So the derivative would be the derivative of the outside times the derivative of the inside. And there's our chain rule in action. We're going to evaluate this at 3. So if I plug 3 into these two expressions, g of 3 we've established was 6, so f prime of 6 times g prime of 3. G prime of 3 is 2. F prime of 6 off of the table is 5, so 5 times 2 equals 10. So we have our two pieces of information to write the tangent line. Our tangent line in a general form is f of the center plus f prime of the center times x minus the center. So L of x is going to be, if we want to do it using the notation here, k of our center plus k prime of our center times x minus our center. And now we'll just substitute in the values that we found. 4 plus 10 times x minus 3. This question is worth 3 points. You get 2 points if you correctly found the slope. So if you were able to take the derivative to arrive at the slope, there's 2 points. And then your third point comes from having the correct tangent line.
He's so bright and milky white, shining down upon the ground. He's so bright, milky white, shining down upon the ground. Everybody look at the moon. Everybody seeing the moon. The moon is white, is milky white. Everybody look at the moon. Oh, yeah, I did a song. Jupiter, I did a song. You ain't got one. Yeah. Oh, I feel sick.
Moving on to part B. Part B, we are given a quotient and we're asked to find the value of the derivative of that quotient at 1. So first off, we'll write our derivative in terms of x. So we have a g and f. So derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. And we want to pay attention the fact that they put g on top and f on bottom. That's less, we do it less frequently that way in class, so be careful and don't go with our usual go-tos, but think about it as the derivative of the top times the bottom. Okay, so we want to evaluate this at 1, so we're going to consult our table. Again, the table for all of these things is going to be along the top, so g prime of 1 is 8, f of 1 is -6, f prime of 1 is 3, and g of 1 is 2, all over f of 1 negative 6 squared. If you clean up the numerator, you'll get negative 54. Clean up the denominator, you get 36. And this is numeric, or if you simplify all the way down, it reduces to negative 3/2. Okay? But it should be noted that the very first expression that we wrote here is an expression for h prime of 1. So that's numerically correct. Now the grading rubric says 2 points for an expression of h prime of 1. So I'm thinking they're giving you 2 points if you have the quotient rule written down, or maybe even 2 points for the quotient rule written like this. It seems a little bit weird, but then they give you 1 point for the answer. So this is probably something that the AP readers discuss at the table, how exactly those 3 points break down, which is tricky, but 2 and 1. All right, moving on to part C. Evaluate the integral from 1 to 3 f prime prime of 2x dx. Now, you'll notice here what we have is a function inside of a function, and this should inform you that this is a U-substitution problem if we want to take the antiderivative. So if I let u be 2x, then du over 2 is equal to dx. So what I really have here is from 2 to 6 of f prime prime of u du over 2. So the antiderivative of f prime prime is f prime, and this is being evaluated from 2 to 6. Or if we wanted to make it so that it is more accessible to us, what we can do is write these 6's in there. So what we have is f prime of 6 minus f prime of 2. And those numbers both exist on the table. We have an entry for 6 and an entry for 2 at f prime. So what we have is 1/2 of f prime of 6 is 5, and f prime of 2 is negative 2, which gives us a value of 7/2. Okay. So this is worth 3 points as well. The first 2 points comes from finding the antiderivative. So this 1/2 f prime of u. That's worth 2 points. And then your third point comes from finding your final answer. So now it should be noted that some people can tackle this problem without actually showing the U-substitution. There are a few people who start to recognize the frequency of these patterns where our inner function is a linear function. So it's possible that some of you may have written the problem like that. But once you get to this point, jumping over here, it's the same going down. All right, be sure to comment, like, subscribe, smash that like button, hit the bell for notifications, ask good questions, and conquer the world.